Let's start off this tutorial by choosing our buttons and switches. Here we can see the most common button, which is the push button. It is a momentary button with only 2 pins, so it's very easy to wire up, and it will probably be the most popular button of choice for your button box. Here we can see the next option, which is our rotary encoder. These are the most common rotary encoders with 3 pins on one side controlling the rotary function and 2 pins on the other side controlling the button function. You can also opt for a potentiometer, which can act as an axis, but you will likely encounter a limited potentiometer which will only go so far in each direction. Rotary encoders are often better because they have unlimited rotary action. Here you can see our next switch, which is the latching switch here. These are often not used because they cause something called the ghosting effect, which is essentially when you switch your latching switch on and keep it on, it can actually cause you to press other buttons when you're pressing other buttons. So let's say you turn on your latching switch, which is, let's say, switch 1, and you want to press switch 3. If you have your latching switch 1 on and you press switch 3, you might actually activate a different switch. So say you press button 3, but you're actually activating button 4. So that's essentially the ghosting effect, where it can cause some problems down the road. So often we would probably use a momentary rocker switch. And it's the same for buttons. Here we can see a latching button switch. It can also cause the ghosting effect. So we want to avoid any type of switch that is always on. Okay, here I have some of the most common buttons and switches. Now what we need to do is create a button matrix. A button matrix is essentially made up of rows and columns. It helps us save some pins so we can use them for other things, such as rotary encoders. So here we create rows and columns. A button matrix works by detecting a button on each row and column. So it's very similar to that of a spreadsheet. So for example, if you need to look for cell A3, you'd go to A, which would be this row, and 3, which would be this column. So this would be cell A3. That's the same way how our Arduino works when we push a button. To line up our rotary encoders, we need to connect the ground pins. The ground pins may vary depending on your rotary encoder, but often they are the middle pin on the 3-pin side. So here we would connect the ground. You can save some pins by connecting all ground to the same output on the Arduino. Now, these next few steps are very important that you get right. So now we need to connect the rotary encoders. We would connect our first rotary encoder here to the first pins, which is TXO for pin 0 and RX1 for pin 1. These are very important steps, as you need to connect each pin for each encoder in the correct order. So for example, here we need to start in pin 1 and pin 0. They must be in a pair. They cannot be at pin 2 and 4, for example. They need to be sequentially ordered. So here we have pins 0 and 1 connected for our first rotary encoder. And we must start on pin 0. We cannot start on pin 2. It is very important that we start on 0 and go sequentially from there. Here we connect our next encoder at pin 2 and 3. So you can see here we are sequentially ordering our rotary encoders. Pin 0, 1, 2, and 3. Then we connect our third rotary encoder here. Then we connect it here to pin 3 and 4. 4 and 5. So there you can see that you sequentially ordered all your pins. That's very important that you get all pins sequentially ordered for your rotary encoders, starting from pin 0.